Hi guys, today we're going to talk about slope or learn about slope. The steepness of a line is called slope. The steepness of a line is called slope. So if we look at these three examples of lines right over here, this line is the least steep line of the three of these, and this line is a little more steep than this one, but this is the steepest line of the three of these, and it also has the biggest slope. The letter we use for slope is a lowercase m. A lowercase m is what we use whenever we want to use or write slope inside of an equation. So like we had y is equal to k times x, we use the letter k for constant. We're going to start using m for slope in our equations. When given the graph of a line, we need to know a simple definition of slope. So if we have slope m, we find rise over run, which will give us the slope of a graph of a line. And what I mean by rise over run is you're going to figure out how far you go up or down to get from point A to point B, and how far you go side to side. So you're going to write, oh, I went 2 units up over, I went 2 units to the right, or something like that. If we look at this example right over here, if we're going to go from point A to point B, we would say we're going this many units up and this many units to the right. Okay, so rise over run, or rise over run. This is my run, and this is my rise. Slope is the ratio of a line's vertical, again, vertical going up and down, change to its horizontal change, or side-to-side movement. So again, slope is the ratio of a line's vertical change to its horizontal change. This is what we mean by rise over run. How far it goes up over how far it goes side to side, or to the right in this case. Okay, how to find slope when given the graph of a line. So it breaks it down into steps, and you guys know I like steps. Well, let's follow step 1. It says mark some points on their line. And they don't mean to start marking points wherever you feel like it. Oh, these look good, right? No. You need to find a cross section where your y and your x lines meet and your graph crosses at that exact point where your x and y lines meet or cross. So this right over here is another good intersection. If we keep going down, right over here is another good intersection. If you look, this point right over here is 2, 0, right? Or if you look over here, it's 1, 2, 3, 4, 1. We went 4 to the right, up 1. If we keep going down further down the line, that's another good point. That's another good point. Okay, so we have a few good points where we have an intersection between our y line and our x line. So it says start from the left, find the rise or the fall. So if we're going from the left, we're going to have to go to the next point over. So to get from here to here, we're going to rise how many units? Well, we rose 1 unit. So we rise 1 unit. And then we have to find the run. We go from here to here. Well, that's 1 and 2 units, right? We're going 1 unit up and 2 units to the right. So our slope is 1 over 2. If we go from this point to this point, we'd go 1 unit up and 1 and 2 units to the right. So 1 over 2. Or our rise is 1 and our run is 2. Whenever you go up on a graph, guys, going up, right? That's always associated with what kind of a movement? A positive or a negative movement? Positive, correct? And then if you're going down, so if you're going from this point to this point, so if we go down, what kind of a movement would that be? A negative movement, right? So if we wanted to figure out how to get from this point or from this point to this point, we'd go 1 unit down, so our rise would be actually -1, and our run would be 1 and 2 units to the left. And remember, going left on a graph is also associated with a negative movement. So this is -1 and -2 because we went to the left. Well, if you look at this slope right over here we have -1 over -2, or we're dividing -1 by -2. What happens when you do that? Well, negative divided by a negative is a positive, so our slope ends up becoming a positive. So you get the same slope. It doesn't matter if you go up and to the right or down and to the left. You should get the same exact answer. Later in the lesson, we will be using a formula to find slope. We will often get fractions that need to be reduced. The images below show 4 attempts at finding the slope of the line above. Can they all be correct? Sorry, before we look at these 4 down here, let's look at this last statement. It says, find the run by going to the right. And it says we will always go right. I'm not a big stickler on that. You can go up and to the right, or you can go down and to the left, because you're gonna end up getting the same exact slope either way. Just you have to make sure that you're designating the correct signs with the correct movement. Again, going up is associated with a positive movement, and going to the right is a positive movement. However, going down is negative and going left is also negative. So just keep those things in mind and you should be fine. Okay, so let's look at these. It says we have to reduce these fractions to see if we have the same exact slope. So if we go from here to here, we get a rise of 1 and a run of 2. Well, that's good because that's what we got up here. Let's look at this one though. They went up 2 and over 4. So rise of 2 and run of 4. Well, if we reduce that, what do we get? 1/2. Well, that checks out, right? That's the same exact slope. So it doesn't matter which 2 points you choose. As long as you do the math correct, you should end up with the same exact slope. Make sure you reduce though, okay? Because they have to be reduced. So this one, again, I'll do this one real quick. They went 1, 2, 3, 4. Our rise was 4 and our run was 1, 2, 3, 4, 5, 6, 7, 8. Run was 8. So 4 over 8, or 4 divided by 8, that gets us 1 over 2, or half. Go ahead and find the slope of these 6 graphs. Make sure that you choose good points that have a good intersection of X and Y. I can't really see them on this display, but I'm sure you guys should be able to find them on your own. I think this one is right over here, and there's a good, intersection right over there. So go ahead and figure it out. How far do you go down and to the right, or how far do you go up and to the left? Either way, you should get the same exact answer. Over here, this one, I think there's a good point right over here, and then another good point, I think, right over here. So practice finding good points that you can use. And even if you miss a point in between, remember you can reduce your fraction to get the correct slope. So it doesn't matter if you pick these two and your friend picks one that's up here and up here. You should both get the same slope when you reduce them at the end. So you're going to finish this side and the coloring activity side, but let's finish up our notes real quick. There are 4 types of slope. Well, we have this slope right over here. If you look at this line, it's moving in a positive, or it's going towards, it's going up, right? As we travel left to right, the graph goes up. As we travel from left to right, the graph is going up. Type of slope, well, it's a positive slope. Whenever it's going up, it's going to be a positive slope. And then over here, we have this graph. As we travel left to right, the graph goes down. And that is a negative slope. I want you guys to find the slope of these 4 graphs also, okay? I might help you out with this one and this one though, because let's look at it. This line right over here, that's the line. And it says the graph is not steep at all, right? It's like driving down the flat road. So there's there's 0 slope. There's 0 slope when you're going side to side. Again, if you're thinking about rise over run, if you think rise, if this is a good point and this is a good point, right? If you pick these 2 points, how far do you go up or down? Well, you go 0, rise, and you go 1, 2, 3, 4, run. 0 divided by 4, well, that's 0. That's why we have a slope of 0. And if you look at this, though, however, a vertical line, this is this graph is so steep, we can't even call it a slope. So if you think about it, you can drive down a 0 slope. However, you cannot drive down this, right? At least I can't in my Prius. So this is an undefined slope, or no slope. Okay, this is a graph of no slope or undefined slope, and this is a graph of a 0 slope. So there's no slope. You can easily drive a car down this road. There's no way in heck you're getting that Prius up this hill, right? You can go up this hill maybe. Whew, you're running down this one though. Okay, so again, go ahead and find the slope of this one and this one. I helped you find the slope of this one because remember it's 0 over 4 or 0 over 1 or 0 over 2. All of those work because all of them will get you the same exact slope. And this one has no slope. So any vertical line has no slope. Good luck, guys, and I'll see you later.